Hello everyone, welcome back to my YouTube channel. My name is Lata from Sri Venkateshwara College of Engineering in the Department of CSE Data Science. Today I am here to explain about F distribution in mathematics. Let us see what is introduction to F distribution. The F distribution, also known as the Fishner-Snedecor distribution, is a probability distribution utilized in analysis of variance, that is ANOVA. It's characterized by its two degree of freedom parameters and the role it plays in hypothesis testing. Definition and properties of F distribution. Let us see what is the probability density function. The F distribution has a sneered shape and is always non-negative. Its probability density function is defined by two sets of degrees of freedom, providing valuable insights into its behavior. Let us see how probability density function works. A statistical expression that defines the likelihood of an outcome for a discrete random variable. Next, variance ratio. It's widely employed to compare the dispersion between multiple groups, making it a fundamental tool in assessing the variability between sample means. Key properties. Let us see properties of an F distribution. As a continuous probability distribution, it's characterized by its long right tail, and its mean and variance are influenced by the degree of freedom. Let us see what is the relationship between F distribution and other probability distribution. First, its similarities. The F distribution shares certain characteristics with the chi-square and T distribution, particularly in the context of hypothesis testing and confidence intervals. Differences. It differs from other distribution due to its specific application in comparative studies involving multiple groups or treatments. And this is the graph of probability density function and cumulative distribution function. First graph shows probability density function and how it varies, and other one shows how cumulative distribution function works. Let us see how to calculate F statistics and degree of freedom. Formula. Calculating the F statistic involves dividing the sample variance of one group by the same variance of another, with the resulting quotient following the F distribution. Degree of freedom. The degrees of freedom in the numerator and denominator are crucial in determining the critical F value for hypothesis testing and confidence intervals. And this is the formula for F distribution. F is equals to s square x divided by s square y. Here nx minus 1, it shows degree of freedom for the numerator. Ny minus 1, it denotes the degree of freedom for the denominator. This is a small example. If we take n1 has 25 and n2 is equals to 22, F distribution, for calculating F distribution we have to follow some steps. In that, first we have to find the larger of the two sample variance. That is, for example, if we take n is equals to 25 and n2 is equals to 22, here n1 is equals to 25 is the larger variance, so that will be the numerator, that will be in the numerator, and then lastly we have to find degree of freedom based on the sample size. Next, applications of F distribution in hypothesis testing. The F distribution is useful in hypothesis testing. Second, hypothesis testing is used by scientists to statistically compare data from two or more populations. The F distribution is needed to determine whether the F value for a study indicates any statistically significant differences between two populations. F distribution. It is also called as a Fishner-Snedecor distribution. Let us see what is the use of F distribution. It is useful for analysis of variance to compare two or more population means, and When it comes to its properties, it continuous and skewed to the right. It contains two degree of freedom, that is numerator and denominator. It is denoted by df, and skewness decreases with increases in degrees of freedom. Let us move on to the F distribution tables and critical values. First, tabulated values. F distribution tables provide critical values for various levels of significance and degrees of freedom, facilitate efficient hypothesis testing and result interpretation. Practical use utilized in determining the rejection region for null hypothesis and establishing the statistical significance of the observed test statistic. Next, limitations and assumptions of F distribution. First, assumptions. One of its primary assumptions is the requirement for the data to be normally distributed within each group being compared. And when it comes to its limitation, it's sensitive to violations of its assumptions, impacting the accuracy of the results obtained through its utilization. Lastly, conclusion and key takeaways. Significance. The F distribution serves as critical tool in statistical analysis, particularly in scenario involves multiple groups and comparative studies. Best practices. Adhering to those assumptions and understanding its application is essential for obtaining accurate and reliable results. Ongoing research. Continuous exploration into the adoption and enhancement of F distribution remains a focal point in statistical research and development. And thank you for watching.